Hello everyone, I'm KK. Welcome to Drive Tech. Let's see what's interesting today.
NVIDIA's latest Toyota story looks like a hardware headline. A smaller autonomous driving computer, lower power, more AI at the edge. But the numbers point to a bigger fight. This is about who builds the brain of the next car, the automaker, the chip company, the software platform, or the AI ecosystem behind all of them. That is why NVIDIA's deeper relationship with Toyota matters. It is not just another supplier deal, and it is not only an autonomous driving headline. The partnership sits at the intersection of three pressures: NVIDIA's need for real-world industrial scale, Toyota's need for an AI-era reset, and China's accelerating smart driving race. The first hook is hardware. NVIDIA's new T3000 module is described as roughly half the size and power of the older T5000, while still targeting similar multimodal inference performance. The T3000 numbers are not small. It is listed with 865 FP4 teraflops, 32 gigabytes of LPDDR5X memory, 273 gigabytes per second of memory bandwidth, and 25 gigabit Ethernet connectivity. NVIDIA also introduced a T2000, a lower-cost option with 400 FP4 teraflops and 16 gigabytes of memory. That matters for mobile robots, industrial manipulators, and edge AI devices. The point is not that every car will use one exact module. The point is that physical AI needs smaller, cheaper, lower power computers that can live inside real machines. The important phrase is physical AI. AI cannot stay inside a chatbot or a data center. It has to move through cars, robots, factories, traffic systems, and warehouses. For that to happen, AI needs sensors, compute, memory, bandwidth, power efficiency, safety logic, and hardware that can survive the physical world. A car is one of the hardest places to put AI. It moves fast, faces rain, glare, heat, cold, vibration, pedestrians, motorcycles, construction zones, and millions of edge cases. So a smaller autonomous driving computer is not only a spec sheet improvement, it is a sign that high-end AI compute is being pushed toward mass deployment. NVIDIA's Drive Thor already points in that direction. NVIDIA frames Thor as a centralized car computer, not just a chip for one assisted driving function. The official performance claim is aggressive. Drive Thor can reach up to 2,000 teraflops. Its predecessor, Drive Orin, is listed at 254 TOPS. The developer kit numbers add more detail, up to 1,000 int8 TOPS or 2,000 FP4 flops, 64 gigabytes of LPDDR5X memory, and up to 273 gigabytes per second memory bandwidth. The vehicle I/O also shows what kind of system NVIDIA wants to support: 16G MSL2 camera inputs, 2G MSL3 inputs, and Ethernet data transmission up to 76 gigabits per second for LiDAR and radar. These numbers matter because autonomous driving is not just model intelligence, it is sensor fusion, real-time decision-making, thermal limits, redundancy, and automotive-grade reliability. NVIDIA says Thor can combine automated driving, parking, driver monitoring, digital cluster, infotainment, and rear seat entertainment into one architecture. That is the car brain strategy. Instead of many scattered electronic control units, NVIDIA wants more centralized intelligence inside a software-defined vehicle that can reduce complexity, wiring, weight, integration risk, and update friction. It can also shift more value from traditional hardware parts toward the software and compute. If NVIDIA owns the compute layer, it does not merely sell a board, it becomes part of the operating system of future mobility. But to prove that vision, NVIDIA needs more than keynote benchmarks. It needs partners that can put physical AI into real industrial environments at real production scale. This is where Toyota becomes important. Toyota is not the loudest company in autonomous driving. It is not the company most associated with software-defined vehicles. But Toyota has something most AI companies do not have: global manufacturing scale, supply chain discipline, factory knowledge, and one of the largest installed bases in the auto industry. For NVIDIA, Toyota is not just a car customer. Toyota is a bridge into the physical economy: cars, production lines, logistics, mobility systems, smart city experiments, and eventually robots. The reported Toyota cooperation also reaches beyond driving. It includes Woven City, Omniverse digital twins for assembly lines, Isaac Robotics, and Nematron large language models. That is important because it turns one car partnership into a broader industrial AI testbed. NVIDIA does not want physical AI to remain a slide in a presentation. It wants the stack to touch traffic systems, factory simulation, robotics, and real mobility operations. Toyota gives NVIDIA a physical world where those claims can be tested. But there is also an uncomfortable truth. NVIDIA does not have unlimited perfect partners in the auto industry. China's automakers are among the most aggressive players in smart EVs and assisted driving. They are moving fast, shipping features fast, and collecting real-world driving data at a massive scale. But export controls and geopolitics make deep cooperation with Chinese companies more constrained, especially when the discussion moves from ordinary components to advanced AI compute and platform control. That does not mean NVIDIA has no China exposure. It means the deepest strategic partnership, the kind that defines a future platform, becomes politically and commercially harder. Tesla is not the easy answer either. Tesla wants to own its own chips, its own neural networks, its own driving stack, its own data loop, and its own robot platform. For Tesla, letting NVIDIA control the core driving computer would create a dependency in the most strategic part of the vehicle. That is exactly what Tesla tries to avoid. So NVIDIA needs a global automaker that is big enough to matter, industrially serious, and still open enough to rely on an outside AI platform. Toyota is not the flashiest partner, but it is large, disciplined, trusted by consumers, and deeply embedded in global manufacturing. From NVIDIA's point of view, Toyota is a gate into the real world, not just into cars, but into factories, production discipline, supply chains, and mobility infrastructure. Now flip the story. Toyota also needs NVIDIA, maybe more than it wants to admit. Toyota won the hybrid era. It built an unmatched reputation around reliability, manufacturing quality, fuel efficiency, and global scale. But the EV era has been less comfortable. In China especially, the market shifted faster than many legacy automakers expected. Chinese automakers are not only selling cheaper electric cars, they are turning software, cockpit experience, batteries, assisted driving, and fast OTA updates into core parts of the purchase decision. Toyota's financial pressure is already visible. CNBC reported that Toyota's fourth quarter operating profit fell 49%, with pressure from tariffs and intensifying competition from Chinese automakers. The reported operating profit was 569.4 billion yen, far below the 813.28 billion yen analyst estimate. That is a large miss, not a small fluctuation. Toyota's quarterly revenue was still huge at 12.6 trillion yen, but consolidated vehicle sales fell to 2.29 million units, down from 2.36 million a year earlier. Toyota also lowered its operating income forecast by more than 20% to 3 trillion yen for the fiscal year ending March 2027. This does not mean China alone caused Toyota's problem, but the pressure mix includes tariffs, recalls, EV competition, slowing China demand, and Chinese automaker competition. That is why NVIDIA becomes useful for Toyota. Toyota does not just need better driver assistance. It needs an AI-era technology story that can keep up with the market's new expectations. In China, buyers are being trained to expect smarter cockpits, faster updates, stronger assisted driving, and a clearer AI identity inside the car. That changes Toyota's problem. The threat is not simply that Chinese rivals sell more EVs. The threat is that they redefine what a modern car should feel like. So for Toyota, partnering with NVIDIA is not just a technology upgrade. It is the strongest AI lifeline Toyota can realistically grab in this cycle. Now compare that with China. China's smart driving race is not waiting for one perfect global platform to arrive. Huawei ADS represents one route, a powerful technology supplier building a high-end assisted driving brand across multiple automakers. XPeng represents another route, an automaker pushing its own software stack, XNGP, city navigation, and end-to-end AI as part of the car company's identity. BYD represents the scale problem. If smart driving moves into mass-market cars, it stops being a luxury feature and becomes a competitive baseline. A Guoyon's securities report said BYD released what it called China's first automotive-grade 4-nanometer autonomous driving chip, Xuanji A3. The same report described Xuanji A3 as an independently developed 4-nanometer assisted driving chip with Level 3 and Level 4 autonomous driving capability claims. Whether every claim becomes real-world capability is a separate question, but strategically, BYD is telling the market that smart driving will not stay premium forever. Horizon Robotics and Momenta represent the supply chain layer. They show that China's smart driving race is not only about car brands, it is about chips, software, and deployable solutions. This is why the China comparison matters. China is not necessarily ahead in every technology layer, but it is extremely aggressive in turning technology into products. The broader export data also shows the pressure. A Gasgoo dataset described coverage of more than 200 export countries, over 80 brands, and 300 vehicle models. In one 2026 January to April snapshot, Chery was reported up 264% in Europe, while BYD was up 180% in Latin America. Those numbers are not about autonomous driving alone, but they show that Chinese automakers are becoming global competitors, not only domestic price challengers. So Toyota's problem is not one rival. It is a changing definition of the car: electric, connected, upgradable, intelligent, and increasingly global. The American route, led by NVIDIA, is platform first: chips, software stack, simulation, robotics, safety, architecture, and physical AI. The Chinese route is deployment first: cars on the road, feature rollouts, price competition, local road data, and fast iteration under consumer pressure. Both routes have weaknesses. NVIDIA's route depends on partners, regulation, and whether automakers accept outside platform control. China's route faces cost pressure, safety expectations, regulatory scrutiny, and the challenge of proving these systems across messy real-world conditions. But the strategic direction is clear. Cars are becoming AI devices that move through the physical world, and the value is shifting toward whoever controls the intelligence layer. That is why the Toyota-NVIDIA partnership matters beyond Toyota. It is a test case for whether a traditional automaker can borrow AI platform power fast enough. It is also a test case for NVIDIA. Can it become the default computing layer for physical AI, not just the king of data center GPUs? The physical AI angle is not just marketing. A Huafu Securities robotics report cited Jensen Huang, emphasizing robotics and physical AI as directly applicable to industry and semiconductor manufacturing. The same report said NVIDIA and Unitree's reference humanoid platform is around 1.8 meters tall and about 68 kilograms. That is physical AI as hardware, not just software. The report also said a humanoid robotics core company index rose 3.80% during June 1st to June 5th, while the CSI 300 fell 1.54%. That market data is not proof of success, but it shows investors are starting to price physical AI as an industrial theme, not only a lab concept. If NVIDIA can connect data center AI, edge AI, vehicles, robots, simulation, and industrial automation, autonomous driving becomes only one doorway. The larger prize is cars, robots, factories, warehouses, smart transportation systems, and the AI software layer that coordinates them. But if China's automakers keep turning smart driving into a mass market expectation, they will force everyone else to accelerate. That is the real pressure on Toyota. It is not only competing with Tesla or Volkswagen, it is competing with a faster definition of what a car is becoming. This partnership is a mutual choice under constraint. NVIDIA needs Toyota to enter the real industrial world. Toyota needs NVIDIA to regain AI relevance. Neither side is choosing from a perfect menu. NVIDIA's China path is constrained. Tesla is vertically integrated. Toyota's EV and software transition needs help. This also explains why the word platform matters so much. In the old auto industry, suppliers provided parts. In the software-defined auto industry, platform suppliers can shape the whole product cycle. If the driving computer, sensor pipeline, simulation tools, update path, and AI models all come from one ecosystem, the automaker is buying more than hardware. It is buying dependency. That dependency can be valuable. It can reduce development risk, shorten the learning curve, and give Toyota access to capabilities it would struggle to build quickly alone. But it also changes the balance of power. The more intelligence moves into the compute platform, the more strategic leverage shifts toward whoever owns that platform. This is why Tesla refuses to hand over the core. Tesla understands that autonomous driving is not a feature bolted onto a car. It is a control point for the entire business model. This is also why Chinese automakers are moving so aggressively. They do not want to wait until global platform winners are already decided. They want to shape consumer expectations first. If a Chinese buyer starts expecting city navigation, fast OTA upgrades, better cockpit AI, and smart driving as normal features, Toyota's old value proposition becomes less complete. In that world, Toyota's reputation for reliability is still powerful. But reliability has to be paired with intelligence. The car must be trusted, and it must also feel current. So the NVIDIA partnership gives Toyota a way to say, we are not just a legacy manufacturer trying to catch up. We are plugging into the most important AI platform company of this cycle. For NVIDIA, the message is just as important. The company is saying its future is not limited to GPUs inside data centers. Its future also runs on roads, in factories, and inside machines. Once you see it that way, Toyota is not just buying a better driving computer. NVIDIA is not just winning another customer. Both sides are trying to stay relevant in the next platform shift. That makes the partnership less like a luxury and more like a necessity. NVIDIA gets industrial reach. Toyota gets an AI-era story it cannot easily build alone. The future of autonomous driving will not be decided by the smartest demo. It will be decided by who can put reliable AI into the most real vehicles at the largest scale. NVIDIA is betting on Toyota's industrial reach. Toyota is betting on NVIDIA's AI platform. China is betting on speed, scale, and deployment. And that is why one smaller autonomous driving computer points to a much bigger battle, the race to build the brain of the physical AI world.
That's it for today. If this was useful, follow Giraffe Tech. I'm KK. More thoughts on X and Substack. See you next time.